In example A, the population growth of a small country is described by the function where P of t is 28 times the quantity 1.065 to the t, where t is in years and P is in millions. So let's write us a little side note here. T represents years, and P is the population in millions. In part A, it wants us to determine P, the population, at t equals 0, so at the beginning, and then tell us what does that represent. One of the things that we need to remember here is that anything to the power of 0 equals 1. So they're asking us to find P of 0. So when we plug in 0 for our t, this entire base to the power of 0 becomes 1. So we're left with just 28. So notice at time 0, in other words, at the beginning, we are left with our leading coefficient of 28. So that should be of no surprise, because it is our initial amount. So we can interpret this as, at the start, the initial population was 28 million people. Don't forget it's in millions. At the start and the initial might be redundant. Sorry about that. Now in example B, it says, now let's determine the population P when t equals 10. So we're looking for P of 10. We plug in 10 for our t, and this gives us approximately 52.56. So we can interpret this as 10 years after its creation, the population was approximately 52.56 million people. So notice in the first example, we went ahead and wrote it out with all the zeros. In the second example, I didn't. Not a particular reason. I just wanted to show you both ways. Now let's take a look at what the graphs of exponential functions look like. In the example on the left, our b value is 2. If it's greater than 0, which means we have an increasing function. And on the right, we have a b value of 1/2, which is less than 0, which means we have a decreasing function. Let's look at the increasing function on the left first. Do a t-table and find some values in order to graph this function. I always like starting with 0. 2 to the 0 power, well, that just equals 1. So when x is 0, y is 1, would be right there. Let's go ahead and plug in 2. 2 squared will give us 4. Let's go ahead and plug in -2. Remember, negative exponents means reciprocal. So an exponent of -2 means we're at 1/4. So -2 and 1/4 would be right there. So our graph looks something like this. Couple of things that you might notice. First of all, one of the numbers that we didn't plug in was 1. 2 to the first power just gives us 2. Notice we have the point 1, 2. So whenever we plug in 0, we're going to get a 1. Whenever we plug in 1, we're going to get our base. The other thing you might notice is this will never cross the x-axis. We have a horizontal asymptote. And the x-axis is y equals 0, that linear equation. So these 3 facts, those 2 points and that horizontal asymptote, will always exist regardless of what that base is, as long as we're not adding or subtracting or multiplying anything else. Now let's take a look at the next graph where our base is less than 0. We can go back to our xy table. Again, plugging in 0 for x gives us a point at 0, 1, which we knew about. And we can go ahead and go straight to the 1, gives us our base back. Let's plug in 2, it's getting really small. And let's do -2. Remember, negative means reciprocal. So our graph looks something like that. Again, we still have the point 0, 1, the point 1 and its base. In this case, that was 1/2. And Horizontal asymptote at y equals 0. If you've forgotten what the asymptotes are here, with the horizontal asymptote, it is where the graph is approaching, not necessarily touching, although the horizontal you can cross. Vertical you cannot. But the horizontal asymptote, you could cross it, but it is where the y values are getting close to or approaching as x goes towards either positive or negative infinity. Towards the left, our x keeps climbing, but towards the right, this is getting closer and closer to 0. Never equaling 0, but it approaches 0. So notice that the two graphs have the same overall shape, just one is increasing to the right, one is decreasing to the right. And both of those are due to the base of our variable exponents.